Good evening everyone, hope you're keeping well. This is just a quickish video hopefully to run through the Employer Set Project Task 3. This is for the T-Level Digital Production Design and Development course, and it's just a little exploration of what you need to do, which is part 1, which we're going to cover here. So what we're going to do, how you're going to do it, and then what to submit at the end of the assessment. So you've done task 1 now, which is where you are going to go through and you are going to come up with an idea, and then you have to do the Gantt chart and the resource plan, and you have to map that all out and submit it. Then you've done task 2, and task 2 is where you were given some broken code and you had to go through and create a test plan to debug and make sure that the validation on that was working. So now we're moving on to task 3, and this is where you're going to be given a problem that needs solving, and through the power of computational thinking you are going to go through and solve that problem. Okay, so using my handy guide here, I'm going to scroll down to my pre-prepared thing here. So what do you need to do first of all? So you've got 3 hours for this task. Obviously that doesn't give any notice for anyone who needs any extra time or rest breaks, etc. But during those 3 hours you're going to produce algorithm designs to show how you would approach a particular project. So I'm just going to quickly go through and highlight a few bits from the, that is not what I meant to do, go through and highlight a few things from the exam paper itself, okay? So the first bits are just your things that are specified by Pearson, okay? So you must complete the activity within the assessment, has to be done at the date and time set by Pearson, so you can't do this at an additional time. As I said previously, you have 3 hours and you'll be informed of any breaks, etc. You don't have any access to the internet during this, just like the other tasks. You do get access to a CSV file, and we're going to come back to that in a second. So I'm going to quickly highlight this because this will be useful. And obviously the last bit is for your centre, really, of making sure that all your material is kept secure. So let's take a look at this set task brief. Now this is back from a previous example, so obviously I don't know what you're going to get in the exam that's coming up, but we're going to base it on a previous example. So essentially this is just saying that what you're going to be doing is there's a problem that needs to be solved, they're opening it up to your team to solve, and they are giving you a list of the requirements that they've agreed with their client, and you're going to produce some algorithm designs to show how you would implement the system using the requirements that we'll go through in a second. So it needs to communicate the intended solution, and this is a key one here. So quite often people will produce some flowcharts and some pseudocode, which looks amazing, but unless you've annotated it and presented it in a meaningful way, everyone else is not going to understand what it means. So that's really, really crucial. Just because you can understand it doesn't mean everyone else can. Allows the client to make decisions, so they need to be able to look at that and actually figure out, is it going to work, or do they need to make any changes, and then obviously they can give that to somebody else to then create the solution. This is the thing here, it can be pseudocode or flowcharts. Okay, now for the process of this video I'm just going to do flowcharts personally because my brain just works better with flowcharts, but obviously you would apply the same techniques if you were doing pseudocode as well. And like I say, the task 3 data CSV, again, this is really helpful to know because they're going to expect you to use this in your answer, okay? And we'll go through the data in a minute as well so you can see what that's used for. And lastly, this is 17 marks, okay, of the overall project, okay? And we'll go through the mark bands and that in a little bit later. So let me scroll down a bit further. So this is your set task information. Click back onto highlighter mode. So the solution must allow a user to select a flight route and show the trends for passenger numbers over time. It needs to be easy to use, display information in a meaningful way, and make use of text, numerical and graphical, aka in here we have got our pandas. Leave my laptop around here. We have got going to have our pandas and matplotlib here. So pandas, you can see how this is setting you up for task 4A. That is not how you spell plotlib. There we go. Okay, so how are we going to do it is the next question. So as I said earlier, computational thinking at the end of the day. First thing you're going to do is break down what the actual problem is. You're going to identify any patterns, aka anything that's going to repeat throughout the thing. And then lastly, you're going to create a series of algorithm designs. So I'm going to switch pens here, and we're just going to do this. So first of all, how do you do it? I would suggest, I'm going to turn my, oh gosh, that's very loud, isn't it? Turn my laptop around. Didn't realise it would be quite so heavy. So my suggestion to you would be to do this in PowerPoint or Visio if you're doing flowcharts, okay? So this is your flowchart option. Flowchart. I don't recommend doing it in Word because Word gets very funny when you start adding objects and items, and the last thing you want at the end is trying to format your page, okay? So like I say, PowerPoint or Visio for this one. If you're doing pseudocode, You could do Notepad and export it from that, or you could, if you wanted to, do it in Visual Studio. I don't know why you would, or Word or something like that. So Notepad, Word, or Visual Studio. So the very first thing I would do if I was doing this would be to break down the thing. So they want to see evidence of you decomposing the problem, okay? So let me scroll along here. The other thing I added in here, which I thought might be useful, if I can find it again now, I did do it somewhere up here. So I put all of the flowchart symbols in here. Don't know why I put them all out there. So these are the flowchart symbols they're going to expect to see as you do this. I do think, even though the exam board know they are here, a key would not go amiss when you're giving your answer on there, okay? So the first thing you would do is a section called decomposition, or decomposing the problem, or whatever you want to call it. So we have got our solution here is our first thing. So we know that the first thing it needs to do is it needs to choose, there's my answer on here. We can always move this in a bit. Allow the user to set a flight route and show the trends for the passenger numbers over time. So we've got a number of sections of our problem here. So the solution, first of all, needs to allow the user to select a flight route. So it's going to be a departure route. There's going to be a destination route. We need to choose over a number of days or a period of time, I think is what it says on here, and show the trends for passenger numbers over time. Okay, so we will also have a section in here where we will get them to choose a duration of days. And then we are going to have some of our calculations that go on. So then we're going to have our select data and display. Okay, so these are all sections of our solution. So I'm going to put these in rectangles. Oops, sorry, forgive me for keep rotating. So here is one section. Here is another section broken down. So you see here we're decomposing the problem, putting it into parts. Obviously, you would use boxes for this, but I'm being lazy and drawing it on my tablet. So that is not what I meant to draw. Here we go. So you're going to join these all up with arrows, not with the eraser. Arrow here, arrow here, arrow here, and arrow here. And then you're going to break these down further into their processes. So you are going to need to ask the user, so get departure, airport. So this isn't your solution here. This is just you breaking down the problem. You're going to want to validate that information. So you need to obviously make sure they choose a valid airport. And then you are going to store that in a variable as a variable. Okay. And then you're going to do similar on the destination. So you can see here you've already got some things that are starting to repeat. So get destination airport. This is why you don't draw your boxes until you have written your words in. Destination airport. Then you're going to again validate that data. And again store it in a suitable variable. And you're going to go through and do that. So I'm going to go through and fill in the rest of these, and then I will come back once these are all filled in, okay? Okay, so as you can see here, I've now finished my creation. So under my select duration of days, I'm getting the number of days from the user, validating that data and storing it in a variable. And then crucially, selecting the data display. I've got a section in here to import pandas and matplotlib. Import task3.csv, which is why the data is useful. Create a data frame using the departure airport, destination airport, and the number of days, and then return the data frame and create list chart using the data frame, and that's obviously your matplotlib and pandas in there. So that is part one, okay, and that's going to be your general overview that you will create, okay. Then to go with that, you're going to create a series of algorithms based on these sections here. So you could name them 1, 2, 3 and 4, or however many you've got on the day, and then when you go in and create the next thing, obviously you would go, obviously if it was doing number 4, but let's just say we're doing number 1 just for neatness sake. let's do 1, and then you will call it get departure airport. Don't know why mine's not drawing properly. Get departure airport. And then you will go ahead with your flowchart symbols and start creating that. So you will have a start here. And then obviously you will have an input. Let me draw my terrible parallelograms now. So input. And then you could put the variable name in here. So get departure airport. Okay, and then you could say, oh, ugh. Then you probably would go into a is departure airport valid. This is where I do terrible jobs at drawing diamonds, hence why you use shapes. And then obviously remember, these can only ever have binary outcomes, so yes, no, true, false. And then if it is no, you would go, you might have some sort of output that says is invalid, and then try again. You'd obviously put a little bit more detail in than I would, and you probably would also make sure your arrows line up to mine as well. There we go. Right, let's try that again. So that would go there, and then that would go back into here. Always remember to show your directions on here. And then if it was yes, and then we're going to, what have I just done there? And if it's a yes, you're going to then obviously store that. Concept, you've gone mad. Finished. Okay, and if it's a yes, you're going to obviously store that in the system. So you are going to store input. So I'm going to put det airport. Okay, and then that will be the end of our first flowchart. Okay, and then you're going to build those up bit by bit until you have all of the ones for your section. Other things like I suggest you put in there is for each page a key. So you might remember this from like geography days. So you'll have a key here, and then obviously you'll have Terminator, and then you'll have process. Then you might have a, I'm very bad at drawing these, decision, and then your parallelogram will be input output. And something along those lines. And you will do similar if you're doing pseudocode. So probably, regardless of whether you're doing pseudocode or not, I would suggest doing some sort of breakdown like this for that first section, okay? And then go on and then obviously break, instead of obviously doing a sub flowchart for all of these, you would then go on and do some pseudocode for each of these sections on there, okay? And that's how you would create your design. Now let's just have a quick look down at the suggested answers and what you need to submit. I need to come all the way back over here now. So to recap on here, how do you do it? Breaking it down into smaller chunks, which we've done. So you could do that as a flowchart in PowerPoint or Visio, or pseudocode via Notepad, Word, or Visual Studio if you wanted to. Now, in terms of what you need to submit, you need to submit one PDF. Oh my gosh, it's gone mad. One PDF file of your algorithm designs. Please note the format and the naming convention on there. It has to be task-free, document name, registration number, and surname, first letter of your surname, so, of your name. So obviously whatever that design is. But let's have a quick look at the mark bands for this one, so you can see it. So as I said earlier, it's 17 marks. I'm just going to turn my tablet around again. So we're not going to look at band 0 because I like to be optimistic. Okay, nobody's going to submit nothing, so we're going to pretend that band 1 doesn't exist. In fact, I'm going to make it in black so it doesn't exist. All right, so there are 3 things that the examiner is going to be looking for here. First section is how you have broken down the problem. So that's why we do that first task, okay, at the beginning, where you have got the overall problem and then you've broken it down into those sub-strands, okay? How have you broken it down? But that's not just how you've broken down the main task, that's in how you've broken down the sub-tasks as well. So it does filter down into all of those sub flowcharts or pseudocode that follows. Okay, so decomposition is just how well have you broken down the problem? Is it feasible? Application of logical thinking and conventions. You can see this is all based around computational thinking. So how logical is your solution? Does it actually make sense? So have you said get departure airport and then said create a data frame just from that? Well, that's not logical because you need to go back and get the destination airport in there and the number of days. So you can't create the data frame until you've got the departure airport, the destination airport, and the number of days. Okay, so this is where it will need to follow some sort of logical pattern. Okay, and does your structure make sense with that? So are you kind of using the accepted flowchart symbols, and are you using the accepted pseudocode? I will share some of the pseudocode outcomes there. They are quite complicated and difficult to put into a one-page thing because obviously they come from the exam board, but just be familiar with them. And then lastly, how have you communicated it? So this is where I came down to how you submit it at the end. So don't just put all those flowcharts in one document and then go bam, done. There needs to be a logical understanding for the examiner of how you've got there. So I suggest having your first one, which is breaking down the problem into chunks, and then either number or label all of the flowcharts or pseudocode that follow it so they've got the same name. So if you've got a section that's called destination airport, then call that sub flowchart or pseudocode destination airport, so they're all the same. Okay, and that is what I would suggest you do. So you've got 3 hours to do this. I'm sure you'll be absolutely fine because it's quite a relatively simple one. It's just about taking some time to break down the problem. So you might want some paper and pencil in the beginning just so you can have a look at the problem and break it down into parts, okay, and what the various parts are. Any problems or questions, just let me know and I will speak to you soon. Ta-ta!